Hello students. In the question, a matrix is given, that is A equal to 3, 1, minus 1, 2. We have to prove that A square minus 5A plus 7I equal to 0, and hence find A inverse. Hence find A inverse means that you have to find the value of A inverse, that means inverse of matrix, with the help of this equation. Not by any other method, but you have to find A inverse by using this equation, which we have to prove. So let us find A square first. A square, that means A into A. So we have to multiply matrix A 2 times. A is 3, 1, minus 1, 2, multiplied by 3, 1, minus 1, 2. That means I have multiplied the matrix 2 times. Now we know that matrices are multiplied in the manner row into column. That means first row of the first matrix has to be multiplied first to the first column of the second matrix, then first row to second column, after that second row to first column, and then second row to second column. So first let us multiply this first row of the first matrix to this first column of the second matrix. So 3 into 3 plus 1 into minus 1. First row into first column. Now first row into this second column. So 3 into 1 plus 1 into 2. So I have multiplied first row to first column, then first row to second column. Now let us start with the second row. So second row into first column, that means minus 1 into 3 plus 2 into minus 1. Second row into first column. Now second row into second column, minus 1 into 1 plus 2 into 2. So I have multiplied first row to first column, first row to second column. After that I have multiplied the second row to first and second column. Now let us simplify this. This element becomes 3 into 3, 9, minus 1, that is 8. Second, 3 plus 2, 5. This one, minus 3 and minus 2, minus 5. After that, minus 1 plus 4, 3. So this is our A square. Now let us find the value of this equation. The equation was A square minus 5A plus 7I. We have to prove that it is equal to 0. So let us find its value. A square minus 5A plus 7I. The value of A square we have just calculated. It's 8, 5, minus 5, 3. This is A square minus 5 into matrix A. Matrix A is 3, 1, minus 1, 2. This was given in the question. Plus 7 into I. Now I means the identity matrix. Since the given matrix in the question is of 2 rows and 2 columns, hence our I will be identity matrix of 2 rows and 2 columns, that is 1, 0, 0, 1. Now let us simplify this. This 5 will be multiplied inside this matrix to each element. This 7 will be multiplied to each element of the next matrix. So let us do it here. This will become 8, 5, minus 5, 3. This is as it is. Now I am multiplying this 5 inside the matrix. So this becomes 15, then 5 into 1, 5, 5 into minus 1, minus 5, 5 into 2, 10. So I have multiplied 5 inside the second matrix. Now let us multiply the 7. So this is 7, 0, 0, 7. Now let us simplify this. This becomes 8 minus 15, that means minus 7, plus 7, 0. Second element, 5, this minus 5, 0. Third element, minus 5, and this minus minus plus 5, 0, plus 0, 0. Last element, 3, minus 10, minus 7, plus 7, 0. So you can see that I have proved that a square minus 5a plus 7i equal to all elements are 0. That means this is a 0 matrix. So students, we have proved that a square minus 5a plus 7i equal to 0. Now we have to find A inverse using this equation. In order to find A inverse using this equation, what we do is we multiply the whole equation by A inverse. That means each term is to be multiplied by A inverse. So A square into A inverse, 5a into A inverse, plus 7i into A inverse equal to 0. In this way, we multiply each term of the equation by A inverse. Now let us simplify this. This will be a to the power 2 minus 1. That means a to the power 1. That is a minus 5 a into A inverse. See students, just as you multiply x into x inverse to get x upon x, that means 1. Similarly, if you multiply A and A inverse, you get identity matrix. That means just as in simple mathematics x into x inverse is 1, in case of matrices A into A inverse is the identity matrix I. So wherever 1 is written in simple mathematics, in case of matrix you have to write I. So here A into A inverse will be identity matrix I plus. Now this I into A inverse, I just told you that I is treated as you treat 1 in simple mathematics. So if in simple mathematics you multiply 1 into x inverse, that will be x inverse only. Similarly, I into A inverse in case of matrices will be A inverse only. So this I into A inverse will be A inverse. So this is 7 into A inverse equal to 0. Now our aim was to find the value of A inverse. So let us keep 7A inverse this side and take these two terms 5i and A to RHS. So this becomes 5i minus A. Now the value of I we know, I is the identity matrix and A is the matrix given in the question. So 7A inverse becomes 5 into identity matrix 1 0 0 1 minus A, that means the given matrix. The given matrix was 3 1 minus 1 2. Now let us simplify this. This 5 will be multiplied inside the matrix. So this is 5 0 0 5 minus this matrix 3 1 minus 1 2. This remains as it is. So we have 7 A inverse equal to. Now let us subtract these two matrices. 5 minus 3 2, 0 minus 1 minus 1, 0 minus minus plus 1, then 5 minus 2 3. So after subtracting, we have got this. Now our aim was to find the value of A inverse. So take 7 to the denominator. Hence A inverse becomes 1 upon 7 into matrix 2 minus 1 1 3. Or you can take this 1 upon 7 inside the matrix. So this will be 2 by 7 minus 1 by 7 1 by 7, 3 by 7. This is our A inverse. So we have got the value of A inverse using the given equation. That's it. So students, we have got the value of A inverse using the given equation. Hope this answered your question. The next question is integration 0 to 1 x 1 minus x to the power n dx. Now, students, in order to solve this question, we must know a property of definite integral. Property is, if a definite integral is of this form, integration 0 to a fx dx, then it can be written as integration 0 to a f of a minus x dx. That means wherever x is there, you can put a minus x. Where a is what? A is the upper limit of the integration. So in place of x, we can substitute a minus x if limits of a definite integral are of the form 0 to a. Now see, in this question, the limits are of the form 0 to a. It's 0 to 1. That means our a is 1 here. So we can use this property. In place of x, we can substitute a minus x. So let the name of the integration be I. So I is 0 to 1 x into 1 minus x to the power n dx. Now, as I just told you that in place of x, we can substitute a minus x. Our a is 1 here. So in place of x, I am substituting 1 minus x. This I have substituted in the first bracket. And similarly, in the second bracket, this will be 1 minus. In place of x, I am substituting 1 minus x. This is whole to the power n dx. So in the question, wherever x was there, I have substituted 1 minus x. Now let us simplify this bracket. So our I becomes integration 0 to 1 1 minus x. Here, if you open this bracket, this square bracket, this will become, if you open this small bracket, this will become 1 minus 1. Then this minus into minus will be plus x raised to the power n dx. So I have opened this small bracket. Now this 1 and this minus 1 cancel. So we have integration 0 to 1 1 minus x into, we are left with x to the power n here. This is x to the power n dx. Now let us simplify this. Open the bracket. So I will be integration 0 to 1. This 1 into x to the power n, this will be x to the power n minus this x into x to the power n, this will be x to the power n plus 1. We know that in multiplication, powers are added up. Now we have to integrate these two functions and then we have to substitute the limits. Integration of x to the power n we know is x to the power n plus 1 upon n plus 1. Similarly, x to the power n plus 1, this will give you x to the power n plus 1 plus 1, that means n plus 2 upon n plus 2. The limits were 0 to 1. Now you know the method of substituting the limits. First we substitute the upper limit, then minus, then we substitute the lower limit. So first let us substitute x as 1. So this is 1 to the power n plus 1. Now we know that 1 raised to any power is 1 only. So this is 1 upon n plus 1 minus, here on substituting x as 1, this will be 1 to the power n plus 2. Again, it will be equal to 1 only upon n plus 2. If you substitute x as 0, both the terms will become 0. So I am not writing that term because the value of that term we know is 0. Now let us take LCM here. If I take LCM as n plus 1 into n plus 2, This numerator will be n plus 2 minus n plus 1. This is n plus 2 minus n plus 1. Now, if we simplify this n and this minus n will be cancelled. So 2 minus plus minus 1 will become 1. So we have 1 upon n plus 1 into n plus 2. That's it. This is our answer. In the question, it is given that probability of A solving a problem is 1 by 3. Probability of B solving the problem is 1 by 4. Both of them try to solve the problem independently. And we have to find the probability that the problem is solved. Now, students, you see that problem is solved. That means either A solves the problem or B solves the problem. In both the cases, the problem will be solved. So, we have to find the probability of either A or B solving the problem. A or B means A union B. And the formula of PA union B is PA plus PB minus PA intersection B. The value of PA given in the question 1 by 3. Value of PB, this is also given 1 by 4 minus PA intersection B. See, in the question it was given that both of them are solving the problem independently. That means they are independent events. For independent events, PA intersection B is PA into PB. Now we'll substitute the values of PA and PB here also. So this becomes 1 upon 3 plus 1 upon 4 minus 1 upon 3 into 1 upon 4. So this is 1 upon 3 plus 1 upon 4 minus 1 upon 12. This 3 into 4 becomes 12. Now let us take 12 as LCM. If you take 12 as LCM, this will become 3 into 4. 3 4s are 12, 4 3s are 12, 12 1s are 12. So this is 4 plus 3, 7 minus 1, that is 6 upon 12. 6 upon 12. To cancel this 6 and 12, so we have 1 upon 2. So the probability that the problem is solved is 1 upon 2. That's it. Hope this answered your question.